So hello everybody and welcome to the open evening of Fab Lab HRV Botrop. My name is Daniele Ingrassia and I'm going to show you some of my projects. In this case I will especially show you my machine building activities that I've done in the past. So first of all, everything started when I did Fab Academy in 2015. Fab Academy stands for Fabrication Academy. It's basically a course where you learn about digital fabrication in all range of skills. I mean, you will work with electronics, with the laser cutting design, programming, and so on. And one prerequisite to understand what I've done is that everything that I've done was not made by using professional knowledge, like, for example, mechanical engineering and so on. It was just made by me just because I wanted to make it, and I did some experimentations about it. So you might know my work in drones, for example. I've been making lots of drones in the Fab Lab, and I've been building as well lots of machines. Another project that I also worked with a lot is about making circuit boards and making these circuit boards available to be replicated inside Fab Labs. And in this slide, you can see a lot of different designs that I've been using, and each of these designs has a background story. It was meant to be used in a specific case or scenario. So, for example, you can see that this board here with two microcontrollers was the flight controller of my drone, for example. This board where you have this big heatsink here is actually a motor driver, which has been used into my machines, as you can see in this image on the bottom right. These boards here on the right side are the logic controllers from my previous machines. This is another motor driver, for example, a more advanced one. This one is a USB to serial converter. This one is a board that can run at more than 200 megahertz, and it was made for robotics and so on. So all of these electronics has been released as open source, and it's available in my link in GitHub. I will show you later. So this also to tell you that also the electronics from my machines has been designed and manufactured in Fab Labs. So, but before we start, we should have a motivation that we should follow about building machines. And the specific motivation of mine was like, okay, I need a laser cutter. Shall I buy one or shall I make one? I mean, initially it was only okay, we'll just buy one and use it. But then after working with the laser cutter that we have in our Fab Lab, we thought, okay, but let's look how it's made inside. And by looking at it, we discovered that it was not so complex for us. Like how the mechanics was made, how the electronics, how the machine was working was not so difficult. So therefore, we thought, okay, why we don't try to make it completely? And following this approach, more motivation came from the fact that what if you make this machine as open source, so that, for example, many other Fab Labs could try to build it as well. And you also have to know that the laser cutter is one of the most used tools in the Fab Labs because it's the fastest machine in comparison to the, for example, 3D printing technology. So it can make for you a piece in minutes or seconds. So from that, the first machine was born. And the machine that you see on the screen is the first machine that I made. It's a laser cutter machine. And it's called LaserDuo because it integrates inside two different kind of laser sources. So usually in the Fab Lab, you will find a laser cutter which integrates a CO2 laser source. And the CO2 laser, it's able to work mainly with organic and soft materials. So for example, it can work with acrylic, wood, some textile and so on. But this laser cannot work for hard materials. So for example, metals or hard stones and so on. So therefore, the second laser that is integrated is the YAG laser. And the YAG laser, it's able to work with metals. So in the next slide here, you can see the specifications of the machine. So the machine has a very large working area, 1.5 meter times 1 meter. So this means it's almost the same size of a large format CNC machine. So with it, you can easily produce a piece of furniture, for example, or making big banners or big designs. The CO2 laser is under 30 watts, and it's a very powerful laser that we will see it's able to cut almost up to 3 centimeters thickness wood. And there is also the YAG laser, which is 75 watts, which is the laser that works for metal. The YAG laser is the oldest laser that is available for the industry. It was meant to be working with metals, and nowadays it has a very cheap price. So if you have to buy a similar laser as the YAG laser, you can buy the fiber laser, but it's very expensive. You can also see that the machine can move up to 800 millimeter per second. It has a resolution of 1000 dpi. It uses standard stepper motors. The electronics has been made completely by me. And it has also the possibility to move the Z-axis. So not all the laser cutters have the Z-axis that can move. This one has 500 millimeter range of movement. The bill of material, so this means the material cost to make this machine is something expensive because the machine it's huge. So if you have to put the two lasers inside, it will cost you around $10,000. If you only put the CO2 laser inside, then this could cost around $4,000. So if you are interested in making this machine, here there is the link, and here there is the GitHub repository, where the machine is completely released as open source, as you can see from the Creative Commons share-alike license version 4.0. And also here you can find all the files and the information for the replication. So here you can find, for example, the CAD model of the machine made in Fusion. You can find all the electronics over here, for example, the PCBs that you can download to make the controller. And also here you can find some explanation and further information about the machine. You can see also some renderings that have been made with Fusion, the way that the axes have been designed, for example, and some construction. So this was the machine at the initial stage of the building, where basically the outer frame was still not designed. Here, a particular of the X-house system, and here the design of the housing as well, which consists of different metal parts, aluminum parts. And these aluminum parts are also made on purpose so that you can like remove one side and you access the electronic, you remove another side and you access the laser for the calibration, and so on. So this was the machine just before applying the outer enclosure. So you can see it's made by aluminum profiles, basically, and also it has custom-made CNC mill aluminum parts like these panels on the side, and also you can see these parts are all 3D printed parts. And these parts were meant to be used in the adjustment of the housing. So the housing would fit to these parts perfectly. So here the basic housing was done, and this housing was made by first CNC milling the aluminum parts, and then by using a vacuum press machine to make them with the proper bending. And to make this bending also, we had to design the molds. So we had to CNC mill the molds and apply this to the metal sheets in order to be used. So the electronics here, some images about the electronics that are needed. Here there is an image about the vacuum forming machine and also the mold that was under it. This was very long and complex work because once you make the bending, the piece will spring back at a certain point. Therefore, this means that you have to have an angle that is more than the angle that you want. So there are some mathematical formulas and experimentations that can bring you to the right results. We can see a couple of videos about the machine working. So this is cutting MDF, for example. This was one of the first tests that we were doing. You can see how fast the machine is and Also how clean it cuts, so there are no flames, and the edges are really clean over here, and it's going rather fast as well. Yeah. So let's have a look to another video. This is a video of the machine like at maximum speed cutting some thin paper over here. Let's see if it zooms in, so you can see here how fast the machine is going. I mean, the camera was not almost able to take it, and this is a very small design. It's something like 30 millimeter wide, so it's really precise and really fast. There is also a video of the machine engraving PCBs, which was using the second laser source, so the metal laser source, as you can see here. It's now scratching the copper from a copper plate. So with 75 watts, you can, let's say, engrave metal, and you can cut metal, but you need to pass multiple times. It's not possible to pass only one time to make it. So therefore, if you want to cut metal in a faster way, another technology is recommended. So for this, you can cut maybe 0.5 millimeter metal, but with multiple passes, like for example, 10 passes to cut. And the machine was also replicated at Fab Lab in Hamburg, and we built together this with the students. Yeah, you can find more information here. There is also a replication manual. So if you go to the wiki, or wait, there is docs. Yeah, here there is a manual to replicate the machine step by step with the different assembly stages and so on. So if you are willing to try to make it, you can use this manual as a reference to make the machine as well. Yeah, well, I have another couple of videos about this machine. One video is the machine cutting this thick piece of wood. This wood here, it's almost 30 millimeters, and the machine is cutting at maximum power, and it's going, of course, really slow. As you can see, there is like lots of smoke there. So and then after the machine is cut, you can see here it can cut like this thick. So you can make really big pieces of furniture with this machine. You can see the hole over here. It's huge. We also have a video about the machine cutting some textile, for example. Yeah, it's also going rather fast. You can see how it jumps and how it cuts. I also cut some wood with this. Here, some more detail about the cut. I also cut some wood with it. This is the result. You can see here I made this kind of Voronoi pattern, and the machine can really make big pieces. Yeah, here you can see the quality. Yeah, here the textile that was cut, very big textile, and here a detail about the quality of the cut of the machine. Yeah, and here the machine. Yeah, so the area is really big. It's difficult to use the whole area. So here's the 3D model of the machine. As you can see, it has been done in Fusion 360. You can also see removing the housing. How complex is to create such curved shape. This shape was made on purpose to have the possibility to have the feet of the person here. So you can go close to the machine without hitting your feet over here. You can see also the air intakes over here, and over here. And you can also see that the machine integrates a tablet over here that you can use to operate the machine directly. So we can remove the external enclosure to see how it's made inside. You have seen this housing also in picture over here. You can remove the other parts, for example, the body frame, this one. You can see the basic construction of the machine. So you can see here the long x-axis over here, and also you can see the two lasers on the back side. So here is the laser tube, the glass, and here is the YAG laser, where you can see that these have two different shapes completely. And here they have two different mirror sets. So this is one, for example, and this one is the other one. And yeah, they are completely separated because if you have to work with different wavelengths, you need to have different optics. The optics that works for the YAG laser will not work for the laser tube, for the CO2 laser. So, and also the head has two different heads, as you can see. Also with different focal lengths, because of two different lenses here. So every time you use the two lasers, there is an offset between one head and the other head that the software can take into consideration. All right, we can also remove the internal inner enclosure. So you can see also the Z-axis here on the bottom, which is one motor with this long belt and then these 4 lead screws that are going up and down over here. Yeah. All right, I think that was it for LaserDuo. We can close it. Let's go to the next machine, which is this large-scale 3D printer. It's called Big FDM. This machine has been made with the same philosophy of the LaserDuo machine. It's completely open source, and the motivation was to have the chance to have large-scale prints at cheaper cost, because these big printers are very expensive on the market. And therefore I thought, okay, why we don't open source this kind of machines? So the machine is almost completely enclosed, and it has the possibility to move the bed up and down. And here you can see more about the specification. Is 800 by 800 by 900 millimeters. The printing area, it can print typical materials, PLA, PETG, ABS, and so on. It has 2 nozzles that can go up to 1 millimeter. It uses standard stepper motor. It uses linear guides in order to move the different axes, aluminum profiles, and the electronics has also been built by me. There is also a tablet integrated that can be used to control the machine. The bill of material for this machine is around $3,000. Also, this machine has been released as open source. You can find here the repository where you can download all the files and so on. So here there is a little bit of description, some pictures about the quality here of the prints, some description about the mechanics and how it's made. So the machine is made in a way that the outside is completely flat. So then it's very easy to close. So you just need some flat pieces of material to close it. So the glass here is plexiglass, and this is aluminum composite. It's a sandwich between plastic and 2 metallic parts. Here are more details about the design. Here you can see the X and Y stages, the X-axis, the Z-axis. It's made with 4 lead screws and 4 shafts. The bed is something that you can regulate. The housing, and then here the electronics. It's very similar to the one of LaserDuo with some more modifications. So if you are interested also in building this machine has a assembly manual here in the wiki, where you can see some steps about the construction, like first make the frame and then the y-axis and all the parts that are needed to be built. And I also have some videos about this machine, which are here. So this was a workshop that I made in Africa to rebuild this machine. And here is the whole process of constructing the printer. It was 1 week long to build it together with the students. Yeah. Here there is a video about the machine printing. Yeah. And here another video of the machine printing. All right, and this was the second machine. The third machine is a small laser cutter that I built. This machine that you see here in this picture is only the version 1 of the machine. Now we have the version 2, which is here. And so the machine is made on purpose to be a very small laser cutter and to be offered a cheap price for Fab Labs or schools or something like that, because usually laser cutters are very expensive. The specifications are like similar to a tabletop machine. So for example, the cutting area is 600 by 400. The laser is only a 40 watt. But nevertheless, it can cut, for example, up to 8mm acrylic, 15mm poplar wood. It can move up to 400mm per second, and with a resolution of 0.05 millimeter. So the machine is also very safe because it has an emergency button with a key, magnetic switches. It has two sensors on the window that opens and close, and according to this, the laser will stop. And it takes as an input all kinds of different formats, typical formats like DXF, SVG, and so on. So the machine has been made to be a kit. So you can actually buy the kit, and we will give you the instructions about how to build the kit. And in this picture, you can see a bit also about the manual. So the assembly manual is really advanced and well detailed. Yeah, here are some of the possible markets or people that could have it, like hobbyists, makers, Fab Labs, and schools. Here you can see some samples of the laser cut parts. And here there is also a small video, the machine cutting. Yeah. So this is 3mm MDF. And yeah, you can see how precisely it cuts, also without any smoke. Yeah, here there is an example of the machine making the engraving of a picture. And yeah, here a little bit about the quality. And also here there is a very small engraving, as you can see. It's these lines are around about 0.3 millimeter thick. And here there is 1 cent coin, just to show you how precise it could engrave. I also have we also have the website for this machine, which is fabulaser.net. And here you can see more about the machine, and you can see more information. I also have a couple of videos of the machine here. For example, this is a marking video. So the machine doesn't cut through, but it marks the material really precisely and at a very high speed, as you can see here. And we have been doing also some heavy tests for this machine. Yeah. Here there is a video we tested to the maximum, to the minimum speed and to the maximum power. And here is the machine cutting 10mm acrylic. So 8mm acrylic can be cut at good speed. 10mm is really on the limit of the cut, as you can see here. Yeah, and if you are curious to see the model, here is the model of the machine, so you can also have a look briefly how it's made. It's very simple construction. It's made to be cheap. For example, here is how it's made inside, and here all the electronics and laser tube over here. It's actually a very fun project to be built together with the students of a school. And in the manual is also explained how you can calibrate the machine in order to have an optimal quality cut, and so on. So we have just been developing a filter system, open source filter system, and This is the system that we are developing with active carbon. And we will also supply this with a filter. So you can decide to have the filter that goes inside directly indoor, so you can use it indoor, or you can also attach the exhaust to the outside of the window, and then you can have it outside. And with this, we have concluded our lecture. I would like to really thank the participants, and if you have questions, you can reach out me on Discord. Bye bye.